Hello, hello, hello. We are just starting with our program. I request everyone to keep their mobile phones on silent. And we are just starting. I also request everyone to kindly settle in their respective locations. Good afternoon, ladies and gentlemen. I welcome all the dignitaries. I welcome our chief guest, Shri Asit Saha, Director General, Geological Survey of India, along with our guest of honor, Ms. Priyanka Singla, IAS Special Secretary, West Bengal, and all the other dignitaries who have joined us on this auspicious occasion. I welcome them all. Good afternoon, ladies and gentlemen. I, Ritika Luthra, geologist, GHRM Center, GSI, extend a warm welcome to each one of you on this momentous occasion as we gather here to commemorate the first anniversary of the National Landslide Forecasting Center, NLFC. ये केवल एक वर्ष की उपलब्धि का अवसर नहीं है, बल्कि एक ऐसे दृष्टिकोण और संकल्प का सम्मान है जिसे हमारे भूवैज्ञानिकों, दूरदर्शी नेतृत्व और सभी हितधारकों ने मिलकर साकार किया है। आज का दिन उन सभी प्रयासों का प्रमाण है जो भूस्खलन जैसे प्राकृतिक आपदाओं में जान माल की रक्षा करने के लिए समर्पण, विज्ञान एवं तकनीक के माध्यम से किए गए हैं। To begin this auspicious occasion, I take immense pleasure in welcoming our chief guest, Sri Asit Saha, Director General, Geological Survey of India. May I request Dr. Saibal Ghosh, DDG, NMH4 PND, to kindly welcome him with the traditional Uttariya. We are honored to welcome Ms. Priyanka Singla, IAS, Special Secretary, West Bengal State Disaster Management Authority, our esteemed guest of honor for today's function. May I request Dr. Harish Bahuguna, DDG, Mission 4A, to kindly welcome Madam Priyanka Singla by presenting the Now, I request Dr. Saibal Ghosh to welcome Dr. Joydeep Guha, ADG, HOD, CHQ, GSI. Following that, I again request Dr. Harish Bahuguna to welcome Dr. Joesh Bagchi, ADG, PSS. I now invite Shri Bhupendra Singh Negi, Director, NLFC, to welcome Dr. Somnath Datta, TDG, IMD, Kolkata. I also request Dr. Rakhi Gopal, Director, GHRM, to welcome Ms. Dipali Jindal, Senior Consultant, NDMA, Ministry of Home Affairs, Government of India. As we all know that GSI is also celebrating 175th year of its foundation, and to mark this, a special medal has been designed by GSI. I humbly request DG GSI sir to kindly present the 175th year commemorative medal to Ms. Priyanka Singla, ma'am. And also to Ms. Dipali Jindal, NDMA. Medals to the presenters will be given away after their respective presentations. The upcoming program will feature formal addresses by the esteemed dignitaries, followed by a highlight of NLFC's key activities and achievements over the past year, and will conclude with a technical session and discussion. To proceed further, I request Dr. Saibal Ghosh to kindly deliver the formal welcome address and provide an overview of the event.
Respected Sri Ashit Saha, Director General, Geological Survey of India. Respected Dr. Joyesh Bagchi, Additional Director General, Policy Support System. Dr. Joydeep Guho, HOD, ADG and HOD CHQ. Ms. Priyanka Singla, Special Secretary, West Bengal State Disaster Management Authority. Dr. Somnath Datta, DDG Regional Meteorological Center, Kolkata from IMD, Dr. Dipali Jindal, Senior Consultant, NDMA, and Sri Vinod Kumar Suman, Secretary, Uttarakhand, SDMA, Dr. DC Rana, Special Secretary, HP, SDMA, Mrs. Hanamba S, IS, Commissioner, Karnataka, SDMA, Dr. Subra Chandra Rao, Director, IITM, Dr. S.R. Meena from Pagoda University, Pagoda, Italy, Professor V.K. Menon, Founder, Member, NDMA, Sri Rahul Gupta, Chief Engineer, MORTH, Sri V.K. Prasad, NCMRWF, Dr. P.M. Roy from NRSC, and all the State Disaster Management Authority representatives who have joined online, and all our HODs who have joined online, and also the senior DDGs, Chief Engineer, and all the functionaries, my colleagues. I heartily welcome you all on this auspicious occasion. The occasion is not that important, but the most important thing is that we want to share some experience which we have gained in the last 1 year, because it's a really, really very vital journey on behalf of Geological Survey is concerned. So this was the plan or the brainchild of our Director General. He thought that let us share our experiences with our stakeholders, with our SDMAs, especially the state government people who are actively working in this hour of the monsoon period when we are facing a lot of landslide hazards in different parts of the country, and so they can also be a little bit experienced from our knowledge that what we have gained in the last 1 year, what advancement from the inaugurations of last year by our honorable minister, what we have achieved so far, and what we have planned to achieve in next 4-5 years. And this is a very, very important occasion for GSI, that this facility has long way to go, because the landslide early warning is a really, really very challenging subject, as you all know, because landslide is a real random process. To model or to forecast those process on a regional scale is really, really very challenging. But this type of model are available throughout the world in many countries. They have experienced little bit of failure in initial period, but if we can sustain our endeavor, then at one point of time, like any other countries, presently 19 countries are having this model in place. So one day we will definitely achieve, and we can reduce the loss of life due to landslide hazards. So this is our mission GSI's, is that at least by the end of Sendai framework, the 2030, we should have a system in place in NLFC, where the NLFC is not a center alone in Calcutta. We have the satellite units in all the state units. Our officers today will have a presentations how our last mile connectivity is helping us to give by giving more meaningful data, so that our models are getting improved day by day. So with this endeavor and with this mission in mind, we have kept a small technical program, very brief. We will be having one lecture from our respected stakeholder partner IMD, how they are, because they are also our main source of input data. And one presentations we have kept from the ISRO, where we will understand that how the space-borne products, especially the interferometry SAR, can be used for the landslide early warning. And then one from the GSI, and another, Dr. Boguna will give you an overview and progress we achieved so far. I wish that this program will be helpful, and it will give a positive message to all of us. Thank you.
Next, I request Dr. Harish Boguna, DDG Mission 4A, to present an overview of the achievements and progress made by NLFC over the past year.
Yeah, a very good afternoon to respected Director General, Geological Survey of India, and the chief guest for today, our guest of honor, Ms. Priyanka Singla, Special Secretary from West Bengal SDMA, all the other secretaries and dignitaries who are present offline and online. A very good afternoon to all of you. I'll give a very quick overview of the progress that this center has made in the last 1 year and what we intend to achieve in the years to come. Next. Yes, so this is where we began last year on 19th of July, when this center was inaugurated by Honorable Union Minister for Coal and Mines, Shri G. Kishan Reddy ji, right at this place. And from there, the expectations skyrocketed from us, from GSI and from NLFC, of course. Next. There is a lag between the system and the screen. I hope that the screen is visible to all the participants who have joined us online. So this is where, what we did on that day, the Honorable Minister launched this user-friendly application, which is meant mainly for crowdsourcing of the data on landslides in particular. And over the past 1 year, we have done a lot of things. There were technical glitches initially. The functionality was a bit issue. And this was mostly in English. We made it bilingual, and that was one of the important suggestions that was given by our Director General to us. And slowly but surely, we have now versions ready for the Bangla and Malayalam, and soon we will be integrating all the major languages in the country that will be integrated with our system. And one of the major steps that recently, 2 days back only, what we have done is, earlier our application was there on the Xamarin. Now we have shifted it to Flutter mode, and this shift will now facilitate us a smooth functionality in terms of even the uploading and reducing the size of the application per se. Now on the right side of it, if you can look at, when we launched into 2024, we were having only 4 windows available. Then in the year that has gone by, we have added the forecast bulletin also to the mobile application, and then the information on the landslides that can also be shared with us. That is incidences we can share. Next one. Right, sir. So this was another, yeah. So this was another feature, the dedicated web portal Bhu Sanket. And in the year that has gone by, the information that is available in terms of the number of incidences and the field validated incidences, that is also available on this web portal, dedicated web portal, and the user number is increasing day by day. Next. I'll come that side. I'll come. Yes. I'll come this side. Yeah. So the other part was, the improvement in the dashboard, the data sources. Yeah, so there were improvements in our dashboard, tremendous improvement in terms of forecast data accessibility via FTP server for real-time uses. Then sharing this through API with the NDMA, ICER, and West Bengal SEOC. That has been achieved in the last 1 year. This is the one, now it has come. The efficiency improvements pertaining to transitioning to a semi-automated framework for bulletin preparation. Earlier we were doing it manually. Now at least we are semi-automated, and very soon will be fully automated as far as the preparation of bulletin in the dashboard is concerned. And new features that we have added is the cumulative rainfall visualization and GIS tools for rainfall threshold maps. Then data utilization in terms of weather models, whether NCOM, GFS or GFS used for landslide forecasting. And very soon we will be integrating the Bharat forecasting system with our system. Now this is another modification addition in our dashboard. As you can see on the right side, 2024 when we started, we were using only 2 models, the NCOM Global and NCOM Regional. But in the last 1 year, we have added GFS, GEFS, and cumulative rainfall AWS integration. And as I said, that Bharat forecasting system will soon be integrated into our system to make it more granular. Now, doing all these things, what we have achieved by doing all these things, that you can see the change from change in 1 year, that from 16 districts that we were covering in 6 states, now we are giving forecast to 21 districts spread across 8 states, of which 18 are experimental and 3 are operational. And the added districts include Kodagu in Karnataka, Idukki in Kerala, Peren, Kohima, and Dimapur districts in Nagaland. So that is the addition that we have made in 1 year by making all these improvements. And as far as our perspective plan is there for 2030, up to 2030, we intend to cover nearly 39 districts across the 19 affected states and union territories. There are, of course, 180 plus districts across the 19 state and union territories, but we will be covering at least one district in each of the 19 affected districts and union territories. Now, side by side, after the completion of last year's monsoon season, we started working on the upgradation plan, and that included our interaction for the ground-based monitoring of the landslide with carrying out site-specific landslide monitoring, for which we are now collaborating, are going to collaborate with IIT Mandi, Amrita University, Kerala University, and there is one collaboration that we intend to achieve with NRSC by integrating multi-temporal INSAR-based remote sensing data for observing ground deformation, and this will facilitate us installation and integration of ground-based sensors in Himachal Pradesh and Uttarakhand through IIT Mandi, then installation of AWS ARGs, ground-based sensors in Wayanad and Idukki districts with Kerala University, and AI-enabled tools with IoT devices with the help of Amrita University in Kalimpong. So the tree that we planted last year is now branching out, fanning out in all directions with more and more ramifications in the activities that we are achieving slowly. And in that off-season phase, we did sign an MOU with CNR IRPI Italy, and soon, very soon, the team from Italy, scientists from Italy, they visited our center. We had a 5 days long interaction with them, not only on the knowledge sharing, but also on how to improve our existing infrastructure. And that, after seeing that facility, this CNR IRPI Institute, they recommended our system through World Food Program to Rwanda. Now the state of Rwanda, they showed interest in our system, and we had an interactive meeting with them online, of course, and very soon we tend to move forward in that direction. In addition, we also staged our global footprints by participating in the International Conference on Landslide that was held in Japan last year, and of course, the API integration that we are very fast achieving. Now, apart from the international and national footprints, we expanded by collaborating with our state partners, the different state disaster management authorities. We have signed MOUs, and 5 of them were signed on 27th of June last month only at Guwahati in the presence of Union Minister, of course. And beyond that, we have been trying to expand through leveraging our partnership, our knowledge sharing, our data sharing, our information sharing with a lot of agencies at the national and state level, whether that was the showcasing our activities at Ministry of Home Affairs, Government of India in the recently held annual Relief Commissioners Conference, NDMA, NDRF, and one detailed interaction we had at Thiruvananthapuram that was held with the team from Kerala SDMA. And in addition, we held nearly 28 outreach sessions and programs on showcasing the features of Bhuskalan mobile application that were held at different stations where our scientists, they had gone there, they outreached the different agencies and showcased the features of Bhuskalan mobile app, and also gave an hands-on practice demonstration how to enter the data into the Bhuskalan mobile application. In addition, sir, I'm pleased to mention that there were interest also shown by other educational institutions who have preferred to have the internship program with us at this center, and a batch from Kolhapur Institute of Technology, they also interacted. They came here, the batch came here, they spent a day here with us, and then there was partnership, leveraging of knowledge, sharing, etc. Now, one may ask that by doing all these, what we have achieved, has there been any sort of validation of what forecast we were doing, giving, and from the ground, what is the scenario? So this is one apt example that last year for 27th September 2024, if you see a single day 200 landslides, they occurred as predicted. As you can see, the forecast for that day was indicating high probability of landslides. In addition to that, this year we tried a different thing, that in addition to forecast, issuance of forecast, and should there be a revision in the forecast pertaining to rainfall, we tried this method this year, and you see the results. We shared one WhatsApp message on the probability of landslide after the issuance of forecast. When we assess that there may be some, more probability of landslide, as far as the high to very high predictability of rainfall has been predicted by IMD, we cannot revise our forecast bulletin, but we adopted this. And this message was shared with Sri V.K. Suman. He has joined us online. Suman Saab, I'm very thankful to you. And this was the result, sir. Immediately, the Secretary, USDMA, they issued a letter directing their DDMAs to swing into action, take some immediate action on the warning, the alert that we had given to them. I'm also thankful to Madam Honamba from Karnataka, who is Commissioner Karnataka SDMA. I'm greatly thankful to her also. You can see she has immediately issued an order through email to all her deputy commissioners. We are sharing experimental forecast bulletin at this stage, but now she has ensured that all the DDMAs and other officials, they mandatorily use the Bhuskalan mobile application to share the data with NLFC and take the forecast issued by GSI seriously. So this is the effect that we are now realizing only 1.5 months to this monsoon season, sir. And these are the validations that we have experienced this year. You can see for Rudraprayag district, 6th of July, the letter which I had shown earlier, we had issued some forecasting for high probability of landslides, and these are the ground validations that we have recorded from the ground itself. These are the photographs from Ukhimat Tehsil, that is subdivision. Mind you that our forecast is presently confined to the subdivisional level on 50,000 scale. So these are the validation from that subdivisional level. These are another incidences from single day. As you can see, the high probability of landslide being forecasted. And it is not only that July that we started getting these validations, it is 27th of June, again from Uttarakhand, number of incidences, if you can see that are, these are, I can also underline this part, that these are still in the experimental stage. We are not operationalized, but the kind of the validation that we are now getting is something really convincing to us also and to the stakeholders as well. And it was not only with the state of Uttarakhand, we got the validation from state of Nagaland, number of incidences that you can see on the screen with the high probability of landslide, the number of incidences for that particular day for which the forecast was generated, that we have got from the field. So these are the validations, and where from we are getting this validation? One may ask that who all are the people, and these are our backbone. These are the people on ground. They are stationed at our state unit level offices, and they are giving us the information on the real time, on near real time information on the incidences of landslides, as well as the data on the rainfall. And this is the team at CHQ, team NLFC, aptly headed by our National Mission Head 4. So at the end, I can only say that though we are still in the nascent stage, but we are making steady strides. And these small steps will give they definitely give a glimpse of optimism for future robust and fully automated dashboard system, credible forecasting and granularity in the forecast. And through these steady strides, we will achieve the automation for the bulletin preparation, steps for integration of AI ML tools in our system. We will expand, as I said, to 39 districts by 2030 forecast. The crowdsourcing, we are aggressively now outreaching the people, as I have also shown in my presentation. Aggressively we are outreaching the people, and crowdsourcing of the information will definitely going to increase. And all these efforts are going to increase the granularity that we tend to achieve right up to Gram Panchayat level. Thank you so much. Now, as I said, that one more addition I forgot to mention, sir, that we have made in the last 1 year, and that was, sir, preparing the debris flow impact probability map. And that was the lesson that we got last year from Wayanad, that though we had the susceptibility map, the source area was under high susceptibility, but the damage was at the place where susceptibility was low, but the impact was because of the debris flow that has traveled. So now we started from Wayanad itself, and today we are going to have this, we want to mark this occasion by the release of debris flow impact probability map. And for that, I will request Director General GSI to kindly release this debris flow impact probability map for the Wayanad district of Kerala, marking this occasion. So soon, the system will be with you, sir, and with the earnest request to release this debris flow impact model for map for Wayanad district. Thank you so much, sir. And similar maps, now similar model we have adopted, extended for Darjeeling, Kalimpong, and the state of Uttarakhand. And the exercise will be replicated for all the other states and the districts that we are covering through experimental and operational forecast bulletin. So this will be a very, very useful product for all the states that are suffering the vagaries of landslides. Thank you so much, sir.
Now, I request our guest of honor, Ms. Priyanka Singla, IAS, to kindly address the gathering.
Respected DG Sir, GSI, and all the officials of GSI, with the special mention of Dr. Bahuguna and Dr. Saibal Ghosh, with whom the West Bengal's SDMA is constantly in touch. We have Deputy DG IMD, with whom also we have a very close coordination, as well as Senior Consultant NDMA, and all the dignitaries present through VC as well. I am very thankful for nominating the SDMA as the guest of honor. I am representing the West Bengal SDMA. So West Bengal, as we all know, because GSI, we have the privilege that the GSI is located in West Bengal, the headquarters is located in West Bengal. So we have two very sensitive districts, Darjeeling and Kalimpong, and it is also heartening to note that GSI had selected as a pilot project for the forecasting the two districts of West Bengal. And these two districts, we are getting constant forecast, as Dr. Bahuguna pointed out. We are getting constant alerts as well as forecasts from the GSI, which are transmitted to the DDMAs, and from there it is percolated at the GP level. And sir, I think though the forecast model, as sir was saying, it's a very technical, and it is a constant work in progress. So from our end, from the SDMA end also, I think what we are told is that the validation which needs to be done by our volunteers, by our officials, we are trying our best to support the GSI so that the forecasting model becomes even more robust, and hopefully with all the feedback, different SDMAs will be given to the GSI. If there is any, we have given our feedback, there is going to be further refinement in the forecast model, and we congratulate from the SDMA's end to the GSI for completing 170. They are going to complete 175 years, and sir, we continue, and we hope that we get the full support from the GSI, and we are ready to help GSI in whatever way is required. Thank you.
Thank you, ma'am, for your insightful words. May I now request Ms. Jindal, Priyanka Jindal, ma'am, to say a few, Dipali Jindal, to say a few words on this auspicious occasion.
Thank you so much. First of all, a big thank you to DG sir and Saibal sir for inviting NDMA at this particular platform, and a very big congratulations for completing this milestone. So as NDMA, I would like to first of all congratulate, and we truly appreciate this initiative of NLFC. And as recently we have also organized one of the workshop that was 3 M's in 3 hours. The 3 M's were consisting of the mapping, monitoring and mitigation. So mapping, I will say, one of the major pillar of disaster management in case of the preparedness, and GSI is the pillar of this entire foundation thing. So as NDMA, we request that every state should go ahead with the vision of, developing such kind of the technology in which they can lead with the vision of early warning system in their particular vulnerable areas, so that we can be prepared for the worst scenarios also. So thank you so much once again, and congratulations. Thank you.
Thank you, ma'am. इसके पश्चात मैं हमारे मुख्य अतिथि श्री असित साहा, महानिदेशक भारतीय भूवैज्ञानिक सर्वेक्षण से विनम्र अनुरोध करती हूं कि वे कृपया अपने विचार साझा करें और हमारा मार्गदर्शन करें। महानिदेशक महोदय प्रारंभ से ही NLFC के सशक्त समर्थक रहे हैं और अत्याधुनिक प्रारंभिक चेतावनी प्रणालियों के एक समर्पित पक्षधर रहे हैं। इस महत्वपूर्ण अवसर पर उनके बहुमूल्य विचार सुनने के लिए हम सभी उत्सुक हैं।
Good afternoon, Ms. Priyanka Singla, IAS Special Secretary, WBSDMA, ADG and HOD CHQ, Dr. Jaideep Guha, ADG PSS, Dr. Joyesh Bakchi, and Dr. Somnath Datta, DYDG, IMD, Regional Meteorological Center, Ms. Dr. Dipali Jindal, Senior Consultant NDMA, and all other dignitaries who have joined us offline and online. Today is a special day in the sense that we have made a journey of 1 year of this establishment of this National Landslide Forecasting Center. As you all know, GSI is the nodal agency for landslide hazard studies, and that actually is a great responsibility on our shoulders. Landslide studies, it doesn't mean that GSI is the only organization which is associated with landslide hazard studies. There are many other academic institutions, research institutions who suo moto take up this type of studies and contribute to the greater cause. But GSI has been given the responsibility as a national organization to take care of this menace and provide information. Information is the key for any natural hazard mitigation, whatever it may be. I mean, right from the beginning, if I do not know where landslide may occur, when it can occur, how it can occur, what would be its ferocious nature, I won't be able to take any action on the ground. So that has been the motto of GSI, and as has been pointed out, that we need to know the spatial and temporal distribution of the landslides. We, as a national organization, we started mapping the landslides. And it's not just going and making an inventory of the landslides, but we actually mapped each and every corner of the landslide prone districts. We evaluated the ground conditions, the geology, the geomorphology, the covers, the slope aspect, every aspect which will contribute to generation of this particular hazard which we are calling as landslide. And that is how we have now in place a susceptibility map, using which we can loosely predict, yes, these are the areas where landslide may occur. But that is not the end, as you can all understand. As has been said by Dr. Bahuguna, we are striving for more granular approach, both spatially and temporally. And to that end, all our efforts, all our endeavor is concentrated at this moment. Once again, I reiterate that information is the key. We must have lots and lots of information, and this flow of information has to be non-stop. I mean, we all know that this is the season, this monsoon season is the most dangerous season for us as far as landslide is concerned. And most of our studies have shown that the rainfall is the biggest trigger, apart from the anthropological happenings, the road cuttings, all these issues, indiscriminate constructions in higher reaches, which causes this type of landslides. But if we want to mitigate, if we want to prevent these happenings, once again, we have to have real-time information as well as the legacy information which we have with us. The biggest chunk of information during this monsoon season is provided to us by IMD and its rainfall models, which are used in our early warning system. Continuous research is being done using this data, along with the data which has been collected by us, to refine and make our models more and more robust. We must keep it in mind that our forecast system is a regional one. When we do a forecast, we say about the district. And while doing so, we also try to point out specific areas within that district where it is known from our mapping experiences and from our data collection exercises that which are the more potential areas to have these dangerous happenings during this monsoon season. So at this moment, it's a mixture of regional as well as some sort of granularity. And what we want to do is we want to make it much more scientific, and that is why we have introduced this, this Bhuskalan app, whereby we want real-time ground information from each and every corner. Bhuskalan's main intention is crowdsourcing. GSI officers are there in the field. They are, of course, providing us information. But that is not the end. We would like to have this information from each and every people. And the app has been designed in that manner so that it is easily understandable by anybody, any lay person. And to make it more accessible, what we are doing is we are making it multilingual. It's bilingual at this moment, and within few days it will be get some more languages ingrained into it, which will make it much more palatable to the ground people, the common people who actually gets affected by these landslides. So, collection of information from every corner, from research institutions, from academicians, from the common people on the ground, from the authorities, from the disaster management authorities in the states, in the districts, everywhere we need information. The more information we get, our model will become more robust. Be it through the app or through any means of communication, we need more information. We're hungry for information. Our model needs information. Without information, we will get stuck up. And only with this information, we can go on validating our model and make it more refined and more robust. A time will come when we will be able to probably achieve 100% success rate as far as predicting landslides are concerned, both spatially and temporally. We have been doing a lot of collaborations. As you have noticed that we have done a international collaboration with a reputed institute in Italy. And we have had a legacy of having collaboration with British Geological Survey. And now, at this moment, almost with all the state disaster management authorities, we have collaborations. We also have collaborations with the major infrastructure building agencies in this country. Collaboration and coordination is also a very important factor if you want to mitigate hazards. And why? Because you need information, and there has to be free flow of information. And it can only happen when there is proper coordination, proper collaboration between all the concerned stakeholders and agencies. So today, after 1 year, after this 1 year of learning experience, we should take a pledge once again that this is a menace which needs to be mitigated. And this is not only our job, this has to be our primary goal. And we should take a pledge that we will carry this forward. We will do whatever is needed to be done as a national agency. And my request to all other stakeholders is that please continue doing your research and your studies, but at the same time, help us in building this early warning system as robust as possible, just by providing information in the form of raw data or in the form of any research outputs which you may have, which can help us. This is a national cause. We must keep it in mind. We must rise above our individual pursuits and help this cause of mitigation of landslide hazard effectively. Thank you very much.
Thank you, sir, for your encouraging words and your unwavering support to NLFC. I am happy to mention that more than 57 participants are connected with us online. Let's take now a 5 minutes break for the press brief. I request all the other dignitaries to be present in the hall itself. DG sir will be joining us after press brief.
এটা তো একটা সায়েন্টিফিক অ্যানালিটিক্যাল প্রসিডিওর যার মাধ্যমে আমরা বুলেটিনগুলোকে জেনারেট করি, তো সেটা আজকে অনেক বেশি রোবাস্ট হয়েছে। হ্যাঁ, সুতরাং আমাদের যেটা উদ্দেশ্য ছিল সেই উদ্দেশ্যে আমরা সফল।
মানে একদম সাধারণ মানুষ, মানে যারা ধরুন বা পর্যটক থেকে শুরু করে সেখানকার মানুষ, তারা কতটা উপকৃত হয়েছে, যদি এটার কি কোনো ডেটা বা তথ্য আছে সেখানটাতে, মানে আপনারা যে এই যে লক্ষ্যটাকে আপনারা বলছেন যে সাফল্য পেয়েছেন, সেখানে কতটা মানে সাধারণ মানুষ উপকৃত হয়েছে একদম সব সেক্টরে?
দেখুন, সাধারণ মানুষ উপকৃত হয়েছে কি হয়নি এই খবরটা আপনাকে ডিস্ট্রিক্ট অথরিটিস আরও বেটার বলতে পারবে। আমাদের কাজ হচ্ছে বুলেটিনগুলো জেনারেট করে আমরা ডিস্ট্রিক্ট অথরিটির কাছে দিয়ে দিই। ডিস্ট্রিক্ট অথরিটির কাজ হচ্ছে সেগুলো আরও নিচের লেভেলে, তালুক লেভেলে, পঞ্চায়েত লেভেলে ছড়িয়ে দেওয়া, এবং সেখানে আপনার জনসাধারণের কাছে এই খবরটা পৌঁছে দেবার কাজ তাদের। আমরা যতটুকু গ্রাউন্ড লেভেলে আমাদের অফিসার বা আমাদের এসডিএমদের কাছ থেকে যেটা জানতে পেরেছি যে আমাদের পাঠানো বুলেটিনে তারা উপকৃত হয়েছেন। এটা আপনারা এক্ষুনি কিছুক্ষণ আগে প্রেজেন্টেশনেও দেখতে পেয়েছেন যে যেখানে যেখানে আমরা হাই অ্যালার্ট দিয়েছি সেই সব জায়গায় ল্যান্ডস্লাইড হয়েছে, এবং আমরা আমাদের দেওয়া হাই অ্যালার্টের ভিত্তিতে তারা ওখানে গ্রাউন্ড লেভেলে যথেষ্ট মানে আর কি প্রিকশনারি ব্যবস্থা নিয়েছেন, যাতে দরকার পড়লে ওখান থেকে লোকজনকে সরিয়ে দেওয়া যায়, ওখানে ট্যুরিস্টদের যাতায়াত আটকে দেওয়া যায় বিপদ সংকুল জায়গা বলে। সুতরাং এই সাফল্য তো আমরা পেয়েছি। অ্যাট দ্য সেম টাইম আমরা যেটা করেছি সেটা হচ্ছে আমাদের ওই ভূস্খলন অ্যাপ, যে অ্যাপটা কিন্তু সর্বসাধারণের জন্যে। সুতরাং ওই অ্যাপের মাধ্যমে আমরা যেমন ক্রাউড সোর্সিং করে ল্যান্ডস্লাইড সম্বন্ধে ইনফরমেশন জোগাড় করছি, আবার উল্টোটাও করছি। আমরা ল্যান্ডস্লাইড কোথায় হতে পারে সেই ইনফরমেশনটাও ওর মাধ্যমে দিচ্ছি। সুতরাং জনসাধারণ যদি ভূস্খলন অ্যাপটা ডাউনলোড করে তাহলে কিন্তু তার মধ্যে থেকে তারা কবে কোথায় কি ল্যান্ডস্লাইড হতে পারে এই ইনফরমেশনটা পেয়ে যাবে, এবং তাতে কিন্তু মানে যে আধিকারিক তাদের জন্য ওয়েট করতে হবে না, তারা সরাসরি নিজেরাই জেনে যাবেন যে ওই অঞ্চলে ল্যান্ডস্লাইড হবে কি হবে না।
Let's welcome the first presenter of the evening, Ms. Lovely Chand Rajan, Senior Geologist, SU, Uttarakhand GSI. She is going to present on the topic, Importance of Field Data Collection for Validating Regional Forecasts.
To all seniors who have joined online, मेरा सभी को नमस्कार. I am Lovely Chand Rajan, Senior Geologist, currently posted in State Unit Uttarakhand. Today I am here to present my work and understanding on importance of field data collection on landslide occurrence for validating regional landslide forecasts. The outline of the presentation includes LEWs in Uttarakhand state, the importance of field data collection for validating forecast, the rainfall and landslide data collected since April 2025, forecast versus validation from field, and at the end, glimpse of landslide awareness program conducted in the state. Currently, in Uttarakhand state, we are issuing experimental forecast in 4 districts, which are Chamoli, Uttarkashi, Rudraprayag, and Tehri Garhwal. The daily work related to LEWS in the state includes everyday monitoring and data collection of rainfall from DDMAs between 8:30 hours to 9:30 hours. And also there is monitoring of IMD forecast 3 times a day for observation of weather forecast, rainfall forecast, and weather warning in the district. As the NLFC team issues experimental forecast bulletin, we at state unit disseminate this information if the forecast level given by NLFC team is of orange or red category, or say high or very high possibility of occurrences of landslide, then we at state unit disseminate this information to admins under SDMAs, like to DDMAs, DDMOs, Tehsildar, and sometimes to Naib Tehsildar levels for the confirmation of any incidence of landslide. Once the information is disseminated among the administration for the forecast, and the forecast is released as low, medium, high, very high, we start looking for any incidences of landslide across the districts under study. As of now, in Uttarakhand state, from April 2025, 200 landslide incidences has been recorded. And if we talk about the 4 experimental districts, the count is 184. Why we need to validate the forecast? Because unvalidated forecasts are merely hypothesis. Validation of those forecasts from field transform these forecasts into reliable tools. Without validation or inaccurate forecast or lack of forecast validation affects credibility and also leads to underestimation or overestimation of risk. And it also affects effective resource allocation. So it is very important to validate the forecast and to collect the field data, as with over a period of time, it will definitely enhance our model robustness by increasing the accuracy of the forecast model. Also, it will enable timely warning and preparations and will support informed decision making. As after collecting these field data collection, we will have one robust inventory of landslide, which will help a forecaster to understand about the terrain insights and also about the failure mechanisms, which will in turn will improve spatial and temporal prediction accuracy. Apart from importance of this data collection of landslides for validation, systematic collection of landslide incidents also update our landslide inventory, identifies prone areas very precisely, and will also refine susceptibility maps. Now, how we collect these landslide incidences across these experimental districts? First thing to add here is to record a landslide incidents, we require 4 mandatory parameters, that is date and time of the landslide incidents, latitude and longitude of the landslide, and 1 or 2 photographs of the landslide clearly depicting the incidents. So sometimes we get all these 4 parameters from DDMA control room, sometimes from DGM Uttarakhand and various JE, AE of PMGSY, NHI, DCL, NH and PWD. Those are people who are deployed in different road sectors. Or currently, from this month, BRO has been added to this information inventory, and from these 4, we directly update our landslide inventory. Now, the data we have collected in Uttarakhand is mainly we have collected this information from social media platform. Through social media, we only get the visual of the landslide incidents. What we do then, we collect that basic information about the incidents, like where it has been occurred. Then we contact DDMA control room for the confirmation of the incidents first, and then we request them to provide the rest of the mandatory parameters, like for time, date, and lat long of the incidents. Sometimes they give all the 4 parameters, or most of the time, in our case, they provide us the contact details of local administrator or person who are deployed in different road sectors from PWD, NH, NHIDSL or PMGSY. From there, we ensure to collect all the 4 mandatory parameter of the landslide which is required for the validation of the forecast, and we update our landslide inventory. This is the summary of the rainfall data collected since April 2025, and it is updated till 15 July 2025 in all 4 districts of the experimental forecast. It is 12 years rainfall data from 3 stations of Rudraprayag, 2 years and 4 years rainfall data from 7 stations of Chamoli and Uttarkashi district, 3 years rainfall data from 6 stations of Tehri Garhwal. All these rainfall data has been taken from DDMAs and sometimes from DDMOs also. Also, we are looking for rainfall data from CWC and USDMA. We are also in contact with different state agencies and central government offices in the state for rainfall data. Now, this is a slide showing landslide incidences recorded since April 2025 to 15 July. These are the 2 graphs showing monthly recording of landslide incidences in the 4 districts, and below is the graph showing cumulative landslide incidences recorded from these 4 districts. All these incidences which we have recorded are with all 4 mandatory landslide parameters. Recently, we have achieved this thing, the historical landslide and rainfall data from 2 road sectors of BRO in Chamoli and Uttarkashi, who has given us 243 and 365 landslide incidences. Now, the forecast validation from Chamoli Tehsil for 27 June 2025, where the forecast level given was moderate. This is from Rudraprayag Tehsil for 28 June 2025, where the forecast level given was moderate. This is from Ukhimat Tehsil, Rudraprayag district for 2nd July 2025, where again the forecast level given was moderate. A total of 13 incidences has been recorded in this tehsil, in Mankatia, Gaurikund shuttle parking, and along 3 Yogi Narayan Sonprayag road. Now, apart from validation of the forecast and collection of the landslide incidences across these 4 districts, we at state unit also do landslide awareness program, and up to tehsil and up to district and tehsil levels, and in line with this, we have conducted one workshop on Bhuskalan mobile app in Rudraprayag district covering 3 tehsil, where 71 participants were present. And here we have demonstrated about the mobile application, and hands-on practice were also done. The application, we have told them about the application, uses of the application. This application, as we all know, that is mainly was launched specifically to record the landslide incidences across the country. The takeaway is field validation is non-negotiable, and it is the bedrock of reliable landslide forecasting. Thank you.
I humbly request DG GSI sir to kindly present the 175th year commemorative medal to Miss Lovely Chand. Next, I would like to invite Dr. Somnath Datta, DDG, Regional Meteorological Center, IMD Kolkata, who will be speaking on the topic Impact-Based Rainfall Forecast and its Future Advancements in India.
First of all, I wish to express my sincere thanks and gratitude to the Director General of GSI for kindly giving me an opportunity to speak a few words in this August gathering. So, this is my topic, impact-based rainfall forecast and its future. So, before that, just at a glance, I would like to say this is the vision and mission of IMD. And these are the pillars of IMD. You can see observation and monitoring, research and development, forecasting, sectoral applications, severe weather warning, numerical modelings. These are the different services. You can see very wide range. And IMD has a very seamless weather and climate forecasting strategy. We have nowcasting, which is valid up to 6 hours for all types of severe weather at all districts and 1206 stations. Then after that we have short to medium range forecast, then extended range forecast, which is valid up to 4 weeks, and seasonal forecast, 1 season in advance. This is the weather forecasting, that is the broad structure, you can say. It is an integration of observation, communication, analysis and forecasting and dissemination. And in the observation you can see all sorts of observations we are taking care, which is your conventional, non-conventional, etc., everything. And what GSI DG sir was telling about the crowdsourcing. Crowdsourcing actually it is very, very important, because for example rainfall forecasting. Rainfall forecasting, mainly rainfall forecast for the related to mesoscale weather phenomena, where rainfall does not take place over a wide area, some area only. But not necessary every area there will be some weather observing stations. So that's why if public reporting is there regarding the occurrence of rainfall, then it is very easier for us for the validation of our forecast. So crowdsourcing is very, very important, sir, as you have very rightly pointed out, and it is not only in your service, in our service also. And as we all know that forecasting science, it is basically it is an observational science, and it requires observation from all, actually all. So that's why we have a very robust global observing system with lot of components we can see, which is shown in this picture. And we have a very large observational network, but still I will say that it is also not sufficient. Our department also think it is not sufficient. That's why we are always trying to expand our observation network. And these are different suite of prediction models and tools which I have already mentioned. Multi-model ensemble technique is very, very important, because what happened, already we know that earlier actually we had a concept of deterministic weather forecast. That is, for a given weather phenomena, using a given initial condition, using a given model to generate a single forecast. But the problem with this deterministic forecast is that sensitivity to the initial condition, which was pointed out by Lawrence. So that's why afterwards this new concept came, that is multi-model ensemble. So now multi-model ensemble we are using. So in the multi-model ensemble, more the number of members, more will be the accuracy. But to have more members, we can understand a lot of computational power is required. So HPC and HPC and HPC. We have hydrometeorological support for flood forecasting also. This is the structure you can see. So India Meteorological Department, Central Water Commission, all are there. IMD provides observe and forecast rainfall, and quantitative precipitation forecast also issued by IMD. It is used by CWC as an initial condition for their flood forecasting model. And this is the structure. IMD in the recent years has started flash flood forecast also, and it is very, very useful as such. Now actually earlier IMD used to give only the forecast, but later on throughout the globe it has been realized that by only saying what will be the weather, it is not sufficient. We have to go one step ahead. What this weather is going to do and what others should do. So which comes your impact-based forecasting. So this is a structure. Actually impact-based forecasting, it takes care of many things: hazard, exposure, vulnerability. Accordingly we have the matrix also, risk and response matrix, along with the color code also. So, and it is very internationally agreed methodology. So India Meteorological Department introduced impact-based forecast for heavy rainfall at Meteorological Subdivision in July 2013, at district and city scale in 2019 in its short to medium range forecast, and NAUCAS indicating the likely impact of the heavy rainfall in different sectors and required response actions. The success of IBF of heavy rainfall, this will enhance the management of critical resources like agriculture, water and power, support urban, disaster management sector, etc. And as such, one thing I am telling you, since when impact-based forecast IMD has started, IMD's visibility is really increasing actually. And actually, I should say that this main credit goes to our Director General of Meteorology, Dr. Mrityunjoy Mohapatra actually. Soon after taking the charge of Director General of Meteorology, the first speech he first introduced that we have to go for the impact-based forecasting. Although in other country, advanced country already started, but we started a little later. Now what is the current impact-based forecasting? It is shift from rainfall to impact. IMD now provides impact-based forecast for rainfall, indicating potential impacts on various sectors like agriculture, water resources, power, disaster management. And different components of IBFs are, IBFs consider meteorological hazards, geophysical hazard, just like soil sets, landslide, geospatial application, GSI application, socio-economic conditions, using a wave GIS-based decision support system we are having. This is disseminated at meteorological subdivisions, district, city scales, providing timely information for informed decision making. Examples, there are many examples: forecast detailed potential impact like flooding, landslide, water logging, visibility reduction, collapse of Kacha house wall, traffic disruption, etc. These are the different components as I was telling: flooding, landslide, water logging, all these things. This is a typical example. Actually, IMD gives impact-based forecasting for thunderstorm, heat wave, heavy rainfall. Now, initially, this was our job only. Forecast and warning is with this map. That's all. That is, heat wave conditions very likely to prevail at many places over blah, 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 all this thing and this map. But now we have added this. What will be the possible impact we are indicating, and what are the actions needs to be taken, that is also. Similarly, for thunderstorm and lightning, this was our earlier thing. Thunderstorm with lightning with gusty wind likely to occur at one or two places over blah blah districts, and thunderstorm with lightning with gusty wind 40 to 50 kilometer blah blah district. That's all. But we have added this one. Earlier it was not there. This has been added after 2019 actually. What are the possible impact? What you are not supposed to do, what you are supposed to do. And for thunderstorm, we always indicate one action that use Mosam and Damine. Actually, we have developed many apps here. Many apps we have developed, and we always actually advocate through different media, platform that general public should upload these apps in their mobile actually. For heavy rainfall, these are the thing. Heavy rainfall, earlier we used to give this much only, forecast and warning. Next 24 hours what will happen on such and such day here, and this map only. But now we are telling what are the possible impact and what are the actions suggested. Now there are a lot of technological upgradations are going. IMD is adopting advanced technology like high resolution rapid refresh model for nowcasting. That is, through this model actually your radar picture will be generated, that with where the maximum reflectivity will be there, all this. Then electric weather research and forecasting model, this also we are coming, EWRF for lightning forecast. Then indigenously developed Bharat forecasting system, which we are discussing, with high accuracy forecast. Now regarding this Bharat forecasting system, another one thing I am telling you, Bharat forecasting model, this is a global model. Global model, that means it can give the forecast for the entire globe with a horizontal resolution of 6 kilometers. But sir, for your landslide, as you rightly told, you require information for the regional scale. So actually, along with global model, we are having some regional model also. For example, weather research and forecast model. Generally, regional models can be embedded in a global model. Actually, in this meeting, our sister concern, NCMRF, IITM, they are recognized expert agencies in modeling, atmospheric modeling. I hope they will agree that in this Bharat forecasting modeling system, if the WRF model can be implanted, what is not the correct word actually, embedded, then there is a scope. The WRF model actually can reduce the grid size by 1/3 of the mother's model. In this case, mother model grid size is 6 kilometers, sir, which is a global model. And over that, if the WRF model is embedded over a given interested region, so there actually you can get the information even 2 kilometers actually. So this needs to be explored actually. This needs to be explored because Bharat forecasting system, this itself is a nascent itself. Okay? So, but this has a potential actually. This has a potential. There are many other initiatives also we have taken. That is, IMD is expanding its network for Doppler weather radars and automatic rain gauges, because our aim is that entire our country will be covered by the radar, entire our country, including your coastal region, etc. With the Doppler weather radar, automatic rain gauges. Then enhanced user accessibility. IMD is improving access to forecasts through multiple platforms, including coordinate-based searches, location-based searches, panchayat block-wise section, so that whoever wants how to find, they can do. Integration with other systems. That's why we are now, our secretary, Dr. Ravi Chandran sir, has written to the Chief Secretary of all the states of India, requesting to integrate all the rainfall data collected by the state agencies with IMD rainfall data. Because now actually no one can monopoly for taking the observation. I will only take the observation. Everyone can take the observation, maintaining one standard, WMO standard of taking observation. But thing is, after taking the observation, there is no point in keeping that observation in their own pockets. This will be of no use. So therefore, in the data sharing, one has to be 100% generous. Of course, we have to take care that it should be properly utilized, because nowadays we are also human being, due to temptation and many things we can do. So it should be strictly used only for the national use only. The integration is very much important. Then focus of hyperlocal events, as I was saying, IMD is working on improving the accuracy of forecasts for hyperlocal events, extreme weather events, which are becoming more frequent due to climate change. Then there are some strategic priorities for the future. Strengthening of the early warning system, because now WMO thing is the early warning for all, And in this early warning for all, actually everyone has to take part, from a common citizen to the top scientists, top forecasters also. We aim to enhance our forecasting capability for extreme weather event, reducing lead time and increasing accuracy. Then expanding observational network, as I have already told, leveraging artificial intelligence and machine learning. This is a new dimension, but IMD has already started. In IMD, our Director General already has formed one functional group of scientists. They are in that job actually. Then climate services adaptation also. As the climate variability increases, IMD will focus on providing actionable climate services to help communities adapt and build resilience. IMD has already started providing climate services for the health sector also. Engaging with stakeholders, this is very much required. Collaboration with all stakeholders, including academia, industry, international meteorological organization, will be the key to the advancing our mission, because alone we cannot do anything. Empowering the next generation, and the government of India has launched in one mission Mausam to carry out all these above, so as to lay the foundation for the vision 2047. And these are the mission Mausam objective. This I need not to spend any time, because this is very much available in the ministry website also. These are basic, these are the deliverable, and these are the different expected outcomes. Thank you for kind presence here. Thank you.
Thank you, sir. I humbly request DGGSI sir to kindly present the 175th year commemorative medal to Dr. Somnath Datta. Now I welcome Dr. Priyam Roy, scientist SF NRSC, to present on the topic usefulness of SAR interferometry in landslide forecasting. I request you, sir, to kindly join us online by sharing your screen.
Yeah, I've shared my screen. Is it visible? Yes. Is it visible now? Not yet. Okay, okay. And the slides are changing? Yes. But not in show mode. I think in show mode it creates some problems. Let's try. It's okay. It's changing now? Yes, yes. Good afternoon. Thank you for providing me this opportunity to speak regarding scientific interferometry in landslide forecasting. So, as we all know that synthetic aperture radar is a tool of remote sensing which deals with the microwave domain of the electromagnetic spectrum, and basically it is active remote sensing technique. It sends a pulse on the ground and it receives the pulse back into the satellite and measures a plethora of information. I am in my second slide. Is it okay? Yes. Yes. So now we are entering what we call the golden age of SAR. We have a large number of radar satellites observing the Earth from space, in which across various bands of synthetic aperture radar, which is L, X, C, S, and P, and it is looking at the Earth and getting a host of information. And one of this information is the movement and deformation of the ground using a technique called differential interferometry or interferometric SAR. We are here around 2025, and we are looking forward to the new satellite, which is NISAT, to be launched somewhere down the line in this month or early next month. And we hope to have a large number of information from the satellite as well. The idea about, just very brief, the idea about synthetic aperture radar is that if there's the phase difference from the return pulse can be in the form of a ground deformation, exact measurement of ground deformation. The accuracy of this ground deformation may vary because of the wavelength of the satellite, but the point here is that this phase information resultant from the ground deformation can be translated to an instantaneous measurement of the ground deformation or a more transient movement of the ground, which is in the case of landslides. So when we are talking about the earthquake, the deformation is very rapid and rapid, wherein we have one significant deformation, whereas in the case of landslides, we see that the deformation is more transient, which can also be measured very accurately using this type of phase information from the synthetic aperture of the satellite using this technique called SAR interferometry. Now there's a number of techniques. Of maybe 30 to 40 frames and try to recreate a deformation time series. This is basically a deformation. Landslide prone slope is moving over time. So we know that in the landslide life cycle, there are three phases. There's an early phase, there's a transient phase, and a rapid acceleration phase. The idea is that using this multitemporal INSAR technique and measuring this slope movement over time, can we identify this type of transient landslide, pre-landslide slope motions? And using this information, can we ingest this particular information into a landslide forecasting model to make it more enhanced and more robust and more sound? So this is the intention that we are trying to do here in NRS in ISRO, to ingest the information of slope precursor movements using interferometric SAR, time series interferometric SAR, and ingesting this information into our forecasting model to make it more robust and more meaningful. In this particular technology of multitemporal INSAR technique, there are two mainstream ideas. One is the persistent scatter method, and the other is the small baseline method. The persistent scatter method is basically wherein we have urban settlements, we have corner reflectors or sharp reflectors which are moving over time. It is more pertinent to urban or semi-urban areas. Whereas in the case of landslides, where we use this particularly useful small baseline method, in which it gives the return from a set of pixels which are basically coherent over time, maybe a slope where the pixels are more or less similar looking or similar behaving over time. So in this case, we are primarily using this small baseline method to recreate the deformation time series of the slope to understand if the slope is moving, it is stable, is it in a transient motion, or it is rapidly accelerating. Through the next couple of slides, I will show you examples of how this thing is working in real life and how we can effectively use this to monitor. So this is one case study that we did for the Nainital area. The lake is pretty identifiable, the Nainital area, and this is where we ran the SBAS algorithm to identify this point distribution of movements. Everything that is green here is stable. Everything that is red or blue here is unstable. So the method here is exactly giving us portions of the slope which are unstable over time. And it is clearly demarcating it from the places which are stable. So this northern bank of the lake, which is showing a cluster of red points, is basically where there is a slope creep detected by the method itself, by the interferometric method itself. A more focused identification, everybody identified this landslide. This is the Balyanara landslide of Nainital, south of the lake. It has been a long-term retrogressive landslides happening, periodically activating and reactivating. So the landslide body is here, and you can see this cluster of red points just above the crown of the landslide. And these red points are basically the places of the slope which are moving or showing instability. If you move further towards the ridge line, there's a green cluster of points which is stable. So now if you want to see the movement over time, it comes down to this graph here. the red point is equivalent to this red triangle graph, which we can see is constant. This is displacement and this is time on the x-axis and displacement on the y-axis. And it is moving, as you can see from this deformation time series, that there's a significant amount of movement happening on the slope along this red cluster of points. As opposed to this, the green cluster of points is oscillating around the zero. So there will be always a small portion of noise in the signal, which is showing this acceleration. But the key point is it is just oscillating around the zero, which is basically showing it is stable. Whereas this red cluster here is consistently moving and showing that just the portion above the crown is unstable, and it may happen that in future this section may also fail. So this is the information about the slope, about a portion of the slope which is stable and a portion of the slope which is unstable, that can feed into our landslide forecasting model and tell us more about the possibility of an imminent failure in future. This is a very illustrative case of how the kinematics of the entire landslide can be deciphered using a time series deformation information. So this is the diagram that I talked about. We have an unstable phase. This is a landslide life cycle again. We have a crack in the initial movement, then there's a limited equilibrium, and then either there's a new equilibrium or a acceleration and a collapse. So this is one study we did for the Kotropi landslide in Himachal. We took around 2 years of data prior to the landslide and tried to categorize the movement of the slope leading to the landslide itself, and then tried to correlate the same movement in terms of rainfall. So the black line here, the graph above, is the line, the deformation versus time series. Again, x-axis time, y-axis deformation. And you can see how the slope is moving over time. And every point, every portion where there's an inflection of the graph is correlated to some rainfall, peak rainfall event. So initially it was stable, and then there was a peak rainfall happening around this date here. And the inflection of the curve changed, and it moved into a steady state displacement. And again, there was a transient time where there was no much rainfall. The slope was moving transiently over time. And then suddenly there was one more heavy spell of rainfall on 22nd of July 2017, which triggered the rapid acceleration of the slope, in which basically this slope entered this tertiary cliff phase, eventually leading to its failure on 13th August. So basically, by understanding the entire time series of deformation of the slope prior to the landslide, we can actually understand its kinematics and correlate it with the rainfall to understand which rainfall events triggered the instability and eventually which rainfall event triggered the failure. So this is exactly the history of a slope reconstructed from the time series deformation. Using this time series deformation and using certain mathematical models, we can also right now theoretically predict a day of imminent failure. So there are techniques like inverse velocity or modified inverse velocity, in which we can fit in the information that we get from our displacement time series and calculate an imminent day of failure as per the current rate of movement. So what we need to do is we need to identify the accelerating phase at the end of the time series, the point where the slope starts to accelerate. In theoretical terms, we call this as onset of acceleration, OOA. Once we identify the onset of acceleration, we can fit it into a formula and calculate a possible imminent type of failure. This is a theoretical landslide prediction model. It has been used widely across the world in theoretical domain. And again, we have to see in future how we can fit in this type of mathematical formulation into our landslide forecasting model to actually give a safe prediction window of an imminent failure. So this is the research that we are doing to take it one step ahead. Obviously, this theoretical knowledge and the research that we are doing has to fit into some operational ready model. So we are currently working on this satellite integrated landslide assessment and alert system. In phase 1, we have 3 districts, Darjeeling, which is coincidental with NLFC as well, Rudraprayag and Idukki. We are taking 3 parameters here, the susceptibility, rainfall, as well as all the knowledge that we have incurred from our INSAR displacement time series analysis into a displacement mapping. We're integrating these 3 parameters together into a landslide forecast model and forecasting a landslide, creating a landslide forecast map for the 3 districts, Rudraprayag, Darjeeling, and Idukki. So this is broadly the flow chart. We have two tools through which we are calculating this time series information, the slope deformation information. This is for Darjeeling, and you can see that there is a good coherent distribution of observation points. From each of these observation points, we are trying to identify the displacement time series of the slope versus the deformation versus time. Now you can see that already that there's a large number of points, right? I mean, for Darjeeling, we may have 2 lakh points. It is not possible to identify manually go to each and every point manually and identify the point to be stable, accelerating, or linearly deforming. So herein comes the domain of deep learning. So we have ingested a deep learning model called Fast AI to identify each of these deformation time series through a set of algorithms using a backend ResNet34 model. And we have trained the model using our knowledge, and then deployed it to classify all the possible point observation in the district to 3 categories: the stable, linear, and accelerating. This is from the Ilukan district. And we have classified this deformation time series, and you can see red clusters of points, which are basically accelerating points. You can see green points, which are stable, and yellow points, which are linearly accelerating. So each of these categories, these 3 classes, will have different weightages when it goes into our forecasting model. So now integrating this slope deformation, hill slope deformation map, classified hill slope deformation map, which is basically an outcome of the deep learning as well as the time deformation map. We have integrated with susceptibility and rainfall to create a forecast map. The forecast is generated for today for the next 3 days, for today, tomorrow, and day after. So this is the model that we're working on right now in terms of landslide forecasting in the 3 districts, pilot districts. And we are coming up to an NISR launch, which is coming up in July. And NISR is an L-band satellite. It will give us a plethora of information, even in much more granularity and repeativity over the entire Himalayan terrain. And we're looking forward to this launch coming up in future. We can use this data to further enhance our landslide models, forecasting models. Thank you.
Lastly, I welcome Shri Dheeraj Udapure, Vice President in NLFC.
চাদরটা গায়ে দেওয়া দিয়েছি শৈবাল বাবু আপনি যে চাদর এটা গায়ে দিলে বেশ ভালো লাগবে এখন 22 ডিগ্রি তো 22 আমি ভাবছিলাম এটা গায়ে দেবো এখন ইমিডিয়েট ইউজ হ্যাঁ এটা ফার্স্ট ক্লাস
Good evening to all of you, ladies and gentlemen. I am Dheeraj Udapure. I am the Vice President Technology at SCS Tech India. Amongst the august gathering of such wonderful people out here, I think it's a proud privilege for me on behalf of SCS Tech because we are the system integrators who have designed, developed, deployed, and have operationalized the National Landslide Forecasting Center in conjunction with the Geological Survey of India, Kolkata.
Actually, they are our backend. They are actually maintaining the infrastructure, developing whatever we want.
Post its inception, during the past 1 year, My team has learned a lot of new things. We are also learning things on the go, almost on a day-to-day basis. And we are getting a lot of guidance from the NLFC authorities out here. Based on this experience, we have realized that we can do so much more for future upgradation of NLFC. A quick brief about how I'm going to conduct this presentation in next 10 minutes. I'll give a brief about my company. There's a platform which we have, which is called Intelligent Debriefing with Analytics. I'll give you a brief of that, followed by a small demonstration of a project which is running right now for the Mumbai Disaster Management Agency. I'll give you a live demo of that, followed by a live demo of the same IDA platform for Kalimpong landslide forecasting based on the data that we have collected at NLFC, and a small demo of a co-pilot which we have developed for rainfall-induced landslide forecast. We are a business transformation partner for majorly B2B and B2G businesses. Our head office is in Mumbai. We have presence also in Delhi, Kolkata, Hyderabad and Pune. Apart from that, we have our global offices at Dubai, Singapore and Hong Kong also. I'm happy to tell you that we are a CMMI level 5 system integrator. One of the major specialities of my company is the application development in the geographic information system. We have the capability to develop apps by ingesting data from satellites. We can develop the complete range of hardware, software also. We ingest the data. We can create map layers, application layers for the maps, as well as we can help our customers in modeling of the, in doing the mathematical modeling, thereby completing the entire cycle of analysis, which is absolutely essential for utilization and exploitation of the GIS platforms. I'm also happy to tell you that we have partnered with almost all the major enterprise GIS providers in India as well as abroad, and we are also in the process of developing our own enterprise GIS model called GeoAI. I'll now brief you about something called Intelligent Debriefing with Analytics. It is a comprehensive incident management system that tracks, analyzes, and collates the incident data wherever it happens from multiple sources. Nowadays, as I was seeing the presentation here, crowdsourcing is one of the major sources of information for NLFC. So here, we can do a lot of crowdsourcing from YouTube, from X, from Instagram also. We have developed specialized crawlers which crawl the data from the internet and give the data, feed the data inside our platform. We can take a lot of audio inputs, screen captures, social media, as well as the existing systems. For what? For incident management analytics. So it gives a complete 360-degree view to the user about the incident and its post-analytics. Now, what exactly is an incident? Anything that has a bearing on the final result can be considered an incident. We have the capability to generate the data based on that incident, and this data generated can now be analyzed by our system in conjunction with the user to give a live demonstration of what the system is actually capable of doing. Now I'll give you a small demonstration of the Mumbai Disaster Management Agency, which is being handled by the Mumbai Fire Brigade. You can see here, this is a live dashboard of the number of incidents which are taking place. This is an artificial GIS platform which we have realized. You can go here. Each of these points is actually an incident. Where has it happened? Lat long? When did it happen? What exactly is involved in that incident? Is it a fire call? Some house has collapsed? Or some flooding has taken place there? Okay. This is a master dashboard for the entire thing. Okay. And it gives a complete breakup of the entire incidents also, as well as Mumbai area, metropolitan area itself is divided into 6 different regions. It gives a complete breakup of these regions, and travel time, because response time to a certain incident is also important for the disaster management agency. They send their vehicles, they send their people there. Travel time is also something which we can track on a live basis. Now, this is a master dashboard, but if you want to go more granular, Now, individual instance, now it takes some time to load because it's already hosted on the internet. This gives granularity to the disaster management officials. When did it happen? How did it happen? You can actually track, these are fire station wise top 15 fire stations. You can go and live, it shows you all the fire stations in Mumbai also. What are the kind of incidents that each of the fire stations is actually monitoring, location, time, etc. How much is the response time which each of the stations has taken to respond, because this is important for analyzing the efficiency of each of the fire stations, which are the primary responders. These are the assets, different kinds of vehicles which are used for counteracting the incidents, what kind of vehicles have been used. And we have also developed this final tab, which is a forecast based on the historical data only right now, as well as the changes which we observe in the development of Mumbai as it takes place. So if you just run a slider here, it gives you a complete historical data as well as the how it is going to happen in the next 1 month. These are the incidents forecasts as to what are kind of incidents which are likely to take place on a week-to-week basis. It gives the capability to the disaster management agency to pre-place their resources at various locations and plan the counteracting of the incidents beforehand itself. Having seen this, I'll now give you a small demonstration of what we have done using the data which we have got from the NLFC itself. We have different kinds of temperature ranges here, rainfall ranges here, different kinds of maps also out here. Now if we just have a look at the slider, it gives a visual representation of the different kinds of landslide occurrence which can take place just in the area of Kalimpong. We can do multivariate regression also on the same data, which we've not done right now, but once officially the data is made available to us, then we can do multivariate regression based on different kinds of parameters which we had just seen in the previous presentation, and this can be used for modeling of the landslide prediction in a more accurate manner. This is a small demonstration of the kind of chatbot which we have created for the National Landslide Forecasting Center. You ask questions to them, it gives you the bulletin which is available, which is a static bulletin as of now, can be given to people in a very, very interactive manner. It can happen in two ways. So firstly, based on the user's requirement, we can modify it completely. Secondly, based on the requirements of the scientists themselves who are using this data. Now, right now, there's only one bulletin which is coming throughout the day. We also have the capability to create 3 bulletins, that too automatically once the entire process is fed inside the system. So, this is where I share our vision along with GSI Kolkata for upgradation of the NLFC in the future. I would be happy to answer any queries if you have. Thank you so much, gentlemen and ladies.
I humbly request DG GSI sir to kindly present the 175th year commemorative medal to Shri Dheeraj. The session is now open for discussion from the stakeholders. We look forward to your valuable suggestions and insights.
Thank you, all the presenters. I think the participants and the audience here, they must have benefited from the technical inputs that have been shared through your presentations. Now, coming to the feedback session, sir, I feel privileged to invite Professor Vinod Kumar Menon, who is the founding member of National Disaster Management Authority, Menon Saab, if you are there, kindly bless us with your words. Menon sir.
Thank you very much. I am very grateful to this opportunity to be present and listen to the presentations on the way in which the national the coming years. I would like to congratulate GSI, Dr. Bahuguna, the Deputy Director General of the GSI, for the NLFC's work in terms of understanding the intricacies in terms of deformations which are happening in many landslide prone areas in the country. I recall that in 2005, 20 years ago, when the National Disaster Management Authority was constituted, there was a series of discussions with the experts from the Geological Survey of India, and we have been looking at the role of Geological Survey of India in monitoring landslides in the country over the years. In fact, if you look at the history of the leading apex bodies of the country, like the IMD, the Geological Survey of India, the Survey of India, and many other bodies which were constituted senior experts from the Geological Survey of India over the last years. And I feel that the work which is being carried out by the NLFC in the last 1 year of its formation, the way in which the web portal has actually been providing information has been extremely useful and very valuable. And I feel that the monitoring of deformations in critical infrastructure before, during, and after disasters is very important. And I feel that, especially now with the commissioning of NISAR in the coming weeks, we will actually have an opportunity to look at what was actually presented, the discussions in terms of persistent scatter interferometry using synthetic aperture radar, so PS INSAR, differential INSAR, DINSAR, and many other technology solutions which can actually look at monitoring and the kind of instrumentation which is actually also able to help through geoinformatics, to communicate the information, alerts, and early warning messages to the communities at risk will be also extremely valuable. Actually talks about the kind of requirements in terms of ensuring that the way in which the trends in terms of potential landslides can be monitored very closely, and the information can be communicated to the district authorities for saving lives and protecting livelihoods. I would like to congratulate GSI and also Dr. Bahuguna and the NLFC team for these contributions which they have been doing, and I wish them all the very best. Thank you. Namaskar.
Thank you so much, sir. You are a veteran of disaster management in the country, and we are truly blessed with your wise words. Thank you so much, sir. Thank you once again. Now, moving from the veteran to Matra Shakti, may I now request Ms. Honamba, IAS, Commissioner, Karnataka SDMA, if you are there, madam. Madam Honamba.
Sir, good evening, sir. Firstly, I would like to congratulate on this occasion, sir, and also giving us an invitation to participate in this. It was a very receiving experimental forecast bulletin for Kodagu district. It is really helping us, sir. And we look forward, as it was discussed earlier, for another 6 districts in the coming years also, sir. And we look forward for the support that is extended from GSI, sir. Thank you, sir.
Thank you so much, madam, for your kind words. Active action that you have already taken in Karnataka. We are thankful to you for your quick actions. Thank you so much, madam. Now, moving from the southern part of the country, going towards the north, may I now request Dr. D.C. Rana, Special Secretary, IAS, Special Secretary, Himachal Pradesh State Disaster Management. Dr. Rana, if you are there.
Thank you so much. Congratulations to GSI for completing 1 year of this landslide early warning center, which was established. I was also witness to the opening ceremony virtually, and we have been working with GSI for on this aspect for almost a year now. Experimental landslide early warning is being given for 2 districts. One is the tribal, and second it is the Shimla district of Himachal. In order to see whether the warning matches with the ground reality, we have made WhatsApp group involving Patwari upwards for both the districts. And we have been giving feedback to the GSI, and landslide which are happening on the ground are also being shared with geo coordinates. I think that will help GSI in refining their early warning system. And I'm really, I have a lot of word of praise for GSI because a very professional organization, and whenever we request them, they are always available, and the kind of investigation they conduct, the report they submit, they are actually highly professional. So we wish GSI good luck, and we hope that more and more districts of Himachal will be covered in due course of time. And I think this system will mature in the time to come, and the country would be benefited because landslide for state like us, landslide, mud flows, sinking of villages and area has become a very serious issue for us. In 2023, we lost almost 120 people because of landslides. They were hit by landslides. Rockfall have become a routine thing. So we have to, I think, gradually graduate to from regional scale to maybe localized scale. So I'll request GSI also to start working on that direction also. And there are many technical institutions who are connected today. So I'll also request them to kindly start working, and we collaborate with each other for localized early warning also, so that we can save lives, property, infrastructure, and livelihood. Thank you so much. Good luck and wish you all the best.
Thank you so much, Rana Saab. You are always strength with us. और अब मैं अनुरोध करूंगा, अगर हमारे सचिव उत्तराखंड आपदा प्रबंधन श्री विनोद कुमार सुमन साहब अगर उपस्थित हैं. सुमन साहब, विनोद कुमार सुमन साहब. I think we'll go to the next representative. Or now I will request, see, landslide forecasts are also being useful for other stakeholders, and one of them is Ministry of Road Transport and Highways. And I'm happy to have Shri Rahul Gupta, Chief Engineer, MORTH, Government of India, with us. Rahul Gupta Saab, few words from you.
The work of the National Landslide Forecasting Center is really commendable. Especially, it will be of immense use for operation and maintenance, even in the development of the national highways in the country, especially in the hilly terrains. The models being developed by PSI and ISRO for landslide forecasting will revolutionize the availability of roads to the road users in the hilly mountainous terrain. The problem of landslide needs innovative solutions to make roads safer. The landslide disaster mitigation is dependent on infrastructure augmentation, early warning, and response. We need to build a system which collates satellite and climate geological data to trigger timely alerts and set in motion the standardized response to prevent loss of life and property. As regards Ministry of Road Transport and Highways, one of its affiliate organizations, that is Indian Road Congress, has already come up with comprehensive guidelines on landslide mitigation measures for Indian roads. However, I feel that for long-term and sustainable solutions, the landslide forecasting techniques needs to be dovetailed with the mitigation measures. So we have to formulate and come out with the forecasting measures, either maybe short term to prevent loss of life and property, and long term forecasting measures to ensure that the timely mitigation measures can be taken up. So this requires, because when the mitigation measures for the landslide are there, they are quite costly. So the accuracy in the forecasting has to be ensured. And I wish that this work will go a long way in the development of the national highway network in the country. Not only the national highways, it will be very much beneficial to all the road users across any category of the road. Thank you very much.
Thank you, Gupta Sahab, for the kind words that you have shared with us. And I heard that we are also joined by Dr. I.C. Das from NRSC. So I request Dr. I.C. Das to share his words with us.
So, very good evening to all the participants. This is really a very momentous occasion, I should say. Last year, I remember when this National Landslide Forecasting Center was inaugurated by the Honorable Minister. So the expectation of the country is very high. That's what I just want to underline, because carrying out a PhD on landslide along with Dr. Saival, Dr. Pankaj, and Dr. Tapas in ITC Netherlands, we have understood the global perspective of landslide occurrence and its damage, including what is doing in USA, China, European countries like Germany, then Switzerland. So it's a kind of global menace, I should say. Thousands of people died, South America. But in India, that's what we have discussed, we understood from our European peers, that even though we cannot stop landslide, but we should take a kind of corrective or mitigation measures, at least to warn people, to make them understand the kind of risk involved in the landslide prone areas, particularly for the road sector and the housing and urban sector. That's what I mean. ISRO has also held, rather associated with GSI for carrying out this landslide inventory mapping for using satellite images. We have also published atlas from our side, and we are continuously getting associated with GSI as well as image and NDMA, in all perspective, to help to do the handholding to understand the areas which are prone to landslides. And I should congratulate the GSI team, because it's very challenging. Like last year, we have seen also what happened in Wenad, because landslides, they are so local and so much of uncertainty. Whatever the model we have applied, we have tried globally also. Sometimes
that uncertainty, creeps in, and new areas you are getting landslides. So at least by looking at the frequency, which inventory is being the fundamental to it, and GSI scientists entire country, they have brought a very good database, as I understand from Dr. Saibal Ghosh, a very comprehensive database, verified from the ground, has been utilized under this national landslide forecasting system. So it's basically trying to give a forecasting which is helpful to the decision makers as well as the people of the country at large. So this is really a very good beginning, and we should try to be associated in this and help each other to make it more robust. And like my colleague Priya has given a presentation using the insert data, how we can look at the movement of the unstable slope, and slowly we can understand which are becoming a kind of sign of failure. So those things, if we know in beforehand, it becomes very, rather it facilitates to come out with a kind of risk mapping or alert system. So that is what we are also working on that, and with all the help from GSI, we'll be able to successfully carry out this sensor-based deformation mapping and provide it to GSI under our national meet commitment that we were working with all ministries, where Ministry of Mines is one of the partners. Now, thank you very much for the opportunity, and we extend our full support and cooperation for this NDMA. Thank you.
Thank you so much, Dasab. ISRO, NRSC, they are a valuable partner for GSI as well as NLFC. And this partnership is going to get augmented with the sharing of multi-temporal INSAR data and also after the launch of NISAR. Thank you so much for your generous words. May I now take this opportunity to invite Dr. V.K. Prasad from NCMRWF. If you are there, Prasad Saab. Fine. I think now we move to the, from the country to slightly, to another country. We are joined by Dr. S.R. Meena, who is assistant professor in Padova University, Padova, Italy. If you are there, Dr. Meena. Yeah, please.
Can you? Okay. Good evening, everyone. Yes. Okay. I'm Dr. Sansara Shmina. I'm currently working in University of Padua. So first, I would like to congratulate GSI for National Landslide Forecasting System. I visited GSI last week, so I was able to see the whole system, how it works, how it was developed. But only thing that I want to point out maybe is like I have worked with experts from like my master's PhD was from ITC Netherlands. Then now I'm working with Professor Filippo Catani, and Professor uh, Mario Flores. So we are working more on landslide identification to the risk cycle, complete cycle using AI. So what I want to point out is like as India as a whole, if I look at the country, the GSI, NRSC, or different institutes, academic institutes, my suggestion is like if we use our potential, we already have a lot of data. I have never seen any country which have such data, especially geological data, also satellite data. Like I spoke with Benjamin Merus from National Landslide has a program from USGS. They also still have in the phase of landslide susceptibility. Also, I have friends in British Geological Survey. If you look at the whole global picture of landslide risk cycle, I think now we are entering into a bigger picture in a global scale. And if like the technology that we already have, it can be enhanced by at large scale if we use data centers. Like for example, in Europe we have more computing capacity, but also I spoke with Dr. Bhaguna last week that we can provide any support that you want, because as I'm from India, I'm from Rajasthan, and I will be very happy to assist in any future developments. And for the future, also, if there are any collaborations, I would be very happy to collaborate. Our team in University of Padua in Italy will be also very happy. Thank you so much for the opportunity.
Thank you so much, Dr. Meena. So now what we have done, we have traveled from regional to global, and now coming back to the local, may I now request our own Dr. Jaideep Guha Saab to share a few words with us. You are here since beginning, sir.
The National Landslide Forecasting Center has really traveled a long way. It has been developed over a period of time. It is not. It was inaugurated last year, but before that there was a lot of development and hard work going on, both in terms of creating this particular infrastructure, as well as developing the logic based on which this particular model is working. And as I understand that, like all models, this model will also improve as more and more data gets compiled. So it's an iterative process, and it's really nice to see that already there are talks of plans of not only expanding the coverage but also adding to some of the facilities or adding new functionalities. So I hope that over the next few years NLFC will really become a national center, and maybe a time will come when it should outgrow the Dharitri building and move out, have an independent existence. Thank you.
Thank you so much, sir. You always give some new insights, interesting insights to us. We'll be working on that. So we are fortunate to have amongst these state units, we are having one Deputy Director General, Dr. Shantanu Bhattacharya, with us. He is representing one of the state units, West Bengal. So I earnestly request him to share his thoughts for today's meeting.
Thank you. First of all, I would like to congratulate the whole NLFC team for successfully completing 1 year. They have achieved a lot from 2 districts to 16. And what I suggest is that the achievements and how country has gained, that if they can make a article and publish in the paper, people will come to know. Thank you.
Thank you so much, sir. I may inform you there are 2 articles already in the pipeline under review, so they will be coming up very soon. Thank you so much, sir. And lastly, we would like to hear a few words from the Regional Mission Head 4, who is looking after the activities in West Bengal, RMH Eastern Region, Dr. Debashish Bhattacharya. Quick words, sir.
Thank you very much. Actually, what I can say that this journey, which has culminated in the formation of NLFC and the completion of 1 year, I can remember that Dr. Shoaib Ghosh, when he went to ITC, maybe in the year 2003-4, no? 2007. So he has a long goal and the persistent efforts, and that whatever he has learned during his PhD in the ITC, and after gaining all the experience in GSI right from his the days, formative days in GSI. So I'm really happy that I was a co-worker with Shoaib Ghosh, and GSI with all the partners who are working in these similar fields. So it is a great contribution, And so far we are having, regarding the forecasting that we are habituated, or we are rather, only the visible organization was IMD. So now along with IMD, so GSI is in the equal footing. So I think the nation, the society, and the real public good geoscience, which we call nowadays. So with these, the functions and activities of NLFC, the country will be benefited. Thank you very much.
Thank you, sir. Thank you for your words, inspiring words. And with this, we conclude the feedback session. I profusely thank all the learned participants for sharing their valuable thoughts with us. Thank you, one and all. Thank you so much. And now I hand over the mic to my fellow colleague, Shri Bhupinder Singh Negi, Director, to propose a formal vote of thanks.
Good evening, everyone. It is my privilege and honor to deliver the vote of thanks on behalf of the GHRM team at the conclusion of this enriching and productive workshop. First and foremost, I extend my heartfelt gratitude to our chief guest, Shri Asit Saha, Director General, GSI, for gracing us with your presence and for your inspiring words that set the tone for the workshop. We assure you, sir, that we will give our best to fulfill your vision of NLFC. Our sincere thanks go to our guest of honor, Ms. Priyanka Singla, Special Secretary, Government of West Bengal, for joining us and sharing invaluable thoughts. We would also like to place on record our deep gratitude to Dr. Joydeep Guha, ADG and HOD, CHQ, Dr. Joyesh Bagchi, ADG, PSS, and all the senior officers of GSI present here and connected through online from different GSI offices, whose support and presence have made this workshop a success. I extend my sincere thanks to Dr. Dipali Jindal, Senior Consultant, NDMA, for coming all the way from Delhi and gracing us with your presence on this momentous occasion. A special thanks to Shri V.K. Suman, Secretary, USDMA, Dr. D.C. Rana, Special Secretary, HPSDMA, Madam Honamba S., Commissioner, Karnataka SDMA, Dr. Surya Chandra Rao, Director, IITM, Dr. S.R. Meena, Assistant Professor, Padua University, Italy, Professor V.K. Menon, Founder Member, NDMA, Shri Rahul Gupta, Chief Engineer, North, Shri V.K. Prasad, Director, NCMR WF, Dr. I.C. Das, NRSC, and all the senior officers, scientists from the various organizations who participated online. Your time, attention, and active involvement were instrumental to the success of this workshop. Our heartfelt thanks to Dr. Saibal Ghosh, DDG, and NMH4. Sir, your leadership continues to motivate us in all our endeavors. I would also like to express our deep indebtedness to all the speakers, Ms. Lovely Chandrajan, Senior Geologist, GSI, Drs. Somnath Datta, DDG, IMD, Dr. Priyam Rao, Scientist, NRSC, Shri Dheeraj Udapure, Vice President, SCS Tech, who shared their expertise and knowledge so generously. This engaging session have not only informed and enriched us, but also inspired everyone present here. To our media friends, PRO team, thank you for helping us to share our efforts far and wide. Lastly, I would like to thank Dr. Harish Boguna, DDG Mission 4A, entire GHRM team, our IA, SES Tech, who worked tirelessly to make this event run smoothly. Lastly, thank you once again to everyone for your presence, participation, and support. Thank you very much.
Now I would request everyone to join us for high tea.
Yeah, thank you. Thank you very much.